Solubility product constant KSP. The solubility product constant is a very important term which is specially used in the salt analysis, as this is the term which is going to decide whether the precipitation of a salt will take place whenever its two solutions are mixed or not. This term is related to the solubilities of the salt also, and therefore we first must understand what exactly the solubility is. The solubility term is defined as the moles of a salt required to prepare 1 liter of its saturated solution at a particular temperature. So it is the moles of salt required to prepare 1 liter of its saturated solution at a particular temperature. Because we know as we will increase the temperature, the solution will become unsaturated, the more of the salt is required to prepare the saturated solution. So at a fixed temperature, whatever the moles of the salt required to prepare 1 liter of its saturated solution is called the salt's solubility. Therefore, the solubility which is given a symbol S is expressed in terms of moles per liter, in short called molarity. Now, what is then the solubility product constant is? This constant KSP particularly works for the sparingly soluble salts. Sparingly soluble salts are those salts which are soluble in a very, very small amount, sparingly soluble. Now let us take an example of such type of a salt and let us find out what exactly how this KSP term is derived. Let us take an example of a salt which is called silver chloride. We all know it very easily gets precipitated out, and its precipitates are white in color, and it is often used to detect the chloride ions concentration when the silver nitrate solution is added. Now when this type of a salt is added to water, we know it dissociates to give you silver ions aqueous and chloride ions aqueous. Now if we write the equilibrium constant of this one, it will be silver ions concentration, chloride ions concentration, and AgCl's concentration. Because water is being the solvent, is not, its concentration is not going to change. Now this salt is a sparingly soluble salt. Very, very small amount of this becomes dissociating, it gets dissociated in water. So most of the AgCl remains as such. Therefore, if we multiply this with this one, K, concentration of AgCl, this gives us almost another constant which is called KSP, which will be expressed as Ag ions concentration product with the chloride ions concentration product. So what is KSP is? From this expression, it is the product of molar concentration of the respective ions of the salt raised to the power the coefficients or the number of ions which are obtained from the one molecule of the salt. Let me repeat it again. It is the product of molar concentration of the ions of the salt raised to the power the number of ions given out by one molecule of the salt. So as in case of AgCl, since 1 mole of AgCl gives you 1, or 1 molecule of AgCl gives you 1 AgCl and 1 Ag and 1 Cl, it is the product of Ag ions and Cl ions concentration raised to the power of 1 and 1. Now, the solubility, how the KSP and solubility are interrelated? Definitely Ag ions will have a certain solubility S. Similar will be the solubility for chloride. So how the SS and KSP are related? You can see that the KSP will become what? S square. So S will be the square root of the KSP. So if we know the constant KSP, we can find out the solubility, or if we know the solubility, we can find out the KSP. So this is how these two are related. Let me give you another example to find out what expression for the KSP. The example can be of like barium sulfate. This barium sulfate going to give us barium ions and sulfate ions. Since one molecule of this gives one molecule of barium and one molecule of sulfate, so what we will write is barium sulfate KSP as concentration of barium ions product into the concentration of sulfate ions concentration, and the coefficients or the powers will be only 1 because 1 of barium ions and sulfate ions are given out by one molecule of barium sulfate. So this will be its expression for KSP, and from if the solubility of their ions is S and S, it will be actually, how does the relationship will be, solubility will be under root of the KSP. Let us take example of a salt like silver chromate Ag2CrO4. Now when this salt is added to water, it is going to give us twice of Ag plus ions and a chromate ion concentration. Now therefore, remember, its KSP will be, expression will be twice of Ag ions concentration. Remember why I am taking the twice of this, because 1 mole of this is giving us 2 moles of Ag ions. So whatever is the concentration will become double of it. If this is 0.1, this will become 0.1 of course, but since 2 moles of this are given, it will be twice of 0.1. So that is why the 2 has been multiplied here, and the same will be become the coefficient, because since two ions, Ag ions, are given by 1 molecule of silver chromate, it will be twice of this, and the product is CrO4 2 minus, because only 1 ion is given out by the 1 mole of this salt. So this is what is the expression for this salt of will be there for KSP. And if this, we have to find out how it is related to solubility. Remember, it will be twice of its S, because the solubility will become double, raised to the power 2, and it will be S. So it will be your 4S cube, which will be equal to your KSP. So what your solubility will be? It will be KSP divided by 4 cube root of this. So this will be the expression for the solubility for this particular salt. So in general, let me give you a formula in general how to find out the expression for this one, for the KSP. Suppose a salt is AXBY. It is going to give us X moles of AY plus and Y moles of BX minus. So how we will write down its KSP expression? Remember, it will be X moles of A Y plus to the power X, because if it is twice, it has to be multiplied by twice, and the same becomes the power, and it will be Y BX minus to the power Y. How we will open it? X to the power X, Y to the power Y, A to the power Y plus to the power X, BX minus to the power Y. This will be your KSP. So this is how what we say is the expression for finding out the KSP. And we can put the values of SS, the solubilities here. So what will it will be? It will be X to the power X, Y to the power Y, solubility to the power X, solubility to the power Y. This is how it's KSP. So it will become KSP S to the power X plus Y, X to the power X, Y to the power Y, which can be written as solubility as KSP divided by X to the power X, Y to the power Y, 1 upon X plus Y. So this is in general expression for a salt like AXPY, and from this kind of a general expression we can find out the KSPs or the solubility of any type of salt, and this can give us a lot of valuable information regarding the solubility or the KSP of any particular salt. Now let us do a numerical to understand how solubility is related to KSP. The numerical is find the solubility of barium sulfate if its Ksp is 1.1 into 10 to the power minus 10. Now, how can you find out the solubility of barium sulfate? We know barium sulfate is going to give us barium ions and sulfate ions. Its Ksp expression will be barium ions to the power 1 and sulfate ions to the power 1. So its Ksp will be, if the solubility of these ions is S and S, it will be S into S. And Ksp is already given to us as 1.1 into 10 to the power minus 10. So it will be S square equal to 1.1 into 10 to the power minus 10. So it will be S of square root of 1.1 into 10 to the power minus 10, which will come out to be 1.05 into 10 to the power minus 5. So this is what is its solubility is. So this is how we can find out the solubility from the Ksp value, or if we know the solubility, we can find out the Ksp.